Alright, ladies and gentlemen, in this video we are diving into exponential and logarithmic equations. Specifically for this video, we are going to be looking into solving exponential equations. Anything from the simplest to the most advanced things you're going to see, and then at the end of the section we're going to kind of apply it to some real-world concepts as well too. Let's open the discussion. How do we go about solving both types, really, of these equations specifically? So there are two basic ways to approach these equations, and those two ways are either using one-to-one or inverse properties. Don't forget, our one-to-one properties are as follows. A to the x equals a to the y if and only if x equals y, or otherwise written, log of base a of x equals log base a of y if and only if x equals y. And then for your inverse, remember, this is the two different ways to kind of raise the exponents to the logs. So base a to the log base a of x is equal to x, just like log base a of a to the x equals x as well too. So what does this mean? How do we use these actual properties? Well, we use these properties kind of like we would do in any other type of equation. We would, basic algebra tells us to add a number to both sides of the equation, or subtract, or multiply, or divide, or square root, or whatever the case is, to get a variable by itself. All right? So what we do in a sense with logarithmic properties is the same thing. We may have to log both sides, which kind of sounds odd, or we may have to exponential both sides in order to get these properties in play specifically. All right, so let's take a look. An example, very basic to start some things off with. Okay, so we have 5 different scenarios here. And what I've done, and I want to kind of look on into, is to take the original equation, rewrite the equation so that we can use a property or possibly have to log or do something to both sides of said equation. So let's take a look. In our very first one, we have the original equation of 2 to the x equals 32. So what we're asking ourselves is 2 to what power equals 32? That is what will actually solve this equation. But I want to rewrite it on now because in this example we know that 32 is the same thing as 2 to 5. Well, we have an equation or a property. We just said that if the bases are the same, the exponents must be the same. All right, that is our one-to-one property happening in there. All right, and that was supposed to be equal 0. So what about these two cases? ln of x is minus ln of 3 equals 0. Well, you need to think about it just as you would in algebra, as if you were to get x by itself. So I'm going to add the natural log of 3 to both sides and get it written like this. Well, why do I want to do that? Because the only way that the natural log of x equals the natural log of 3 is if x equals 3. Once again, that's a one-to-one property happening in there. Okay. What about e to the x equals 7? E to the x equals 7. Well, this one's a little bit more of a challenge. However, we can use our things about our properties about our logarithms to rewrite this a little bit. And so in an example like this, where I want to get x out of the exponent, well, what allows me to get x out of the exponent specifically? Well, that's using our inverse functions, our inverse properties, I shouldn't say functions, inverse properties that we are dealing with. Because what do we know? Is that we know the natural log of e to the x is just x. So this means that x equals the natural log of 7. There's an inverse property being used right there. All right. What about here? I probably put some parentheses around this as well. 1/3 to the x. Well, do we all agree that I would say that 1/3, right, is the same thing as saying 3 to the negative x, right? It's the exact same thing that we just did there. That means the exact same stuff. And we also agree that 9 is the same thing as 3 squared. Well, why am I doing this? Because now with the same bases, that means the exponents must be the same, or x must equal -2 for them to work. Once again, here's an example of a one-to-one property being used. And then our last one here, guys, what about for the natural log of x equals -3? So I need to get x away from the natural log. So in order to get x away from the natural log, I'm going to have to use my inverse property to what I call, quote-unquote, e both sides. You're going to e both sides by taking both sides and making them the exponents of your natural base of e. Why is this important to us? Because once again, e to the natural log of x equals x, and e to the -3, well, is e to the -3, right? So e to the natural log of x is x, ladies and gentlemen, and so that allows us to use our inverse property to show that x equals e to the -3 in the end. Let's keep pushing forward a little bit here. Okay, so example 2, solve the equation and approximate to 3 decimal places specifically. So we have 4 to the x equals 72. Well, again, we need to get x out of the exponent. So we have to use some of our inverse properties to do so. And so just how in the last example we e'd both sides, well, to get it away from the exponent, we are going to log both sides this time because we don't have the natural base of e. Instead, we create a common base for 4 to the x. What you do to one side, you have to do to the other. All right. Well, now, what does this do? Well, on the left-hand side, by taking the same base, take a look, you guys. That's exactly our inverse property down here, in which same bases, it will equal the exponent to the log of base 4 of 72. Well, remember, we know our change of base says this is the natural log of 72 over the natural log of 4, and it roughly comes out to be 3.085. All right, so as we kind of wrap a few things on up here, I challenge you, pause the video before we go on over this one, guys. Give this one a shot on your own. See what you can come on up with, and before we go on over it. All right, so what do y'all think? Well, again, just like anything else, I want to get the x by itself. So I'm going to divide, first and foremost, by 3 to get x by itself. And now from there, guys, once again, I need to get x out of the exponent. So we're going to log with a base 2 on both sides. Once again, the reason being is this allows me to use my inverse to say the log base 2 of base 2 to the x equals x. Well, once again, if we're going to solve this one on out, this is the natural log of 14 over the natural log of 2, which is roughly 3.807. All right. So kind of interesting as we're utilizing a few of these different methods here. All right. So let's do one more before we close up for today, and then I'll leave you with one to give a shot on your own. But I want to take a look at this one because it's a very unique and interesting example. I have a question there. It says, what does this remind you of? Any ideas? Think back to Algebra 1, Algebra 2 days. Somewhat kind of looks like a quadratic function, doesn't it? And when we do quadratics, sometimes we use the quadratic formula, or sometimes we even factor out a little bit. We agree that e to the x to the second power is the same thing as e to the x, or e to the 2x. Remember, when you raise an exponent to an exponent, that's like multiplying them together. Why would I do such a thing? Because now I am in quadratic form specifically. So now what's going to allow me? Well, now I need two numbers that are multiplied to give me 2, but subtract or add or subtract to give me a negative 3. So instead of using x like we normally would for a lot of quadratics, what about using e to the x instead? So e to the x, and they're both going to be negative because it's going to be a negative 3. So negative 2 and e to the x minus 1, right? Negative 2 times negative 1 is positive 2. Negative 2 plus negative 1 is negative 3. E to the x times e to the x gives me e to the 2x. So there's my factored form. So now I've got two solutions. I have e to the x minus 2 equals 0, and e to the x minus 1 equals 0. So e to the x equals 2, e to the x equals 1. Well, anytime in this case where I have e to the x, I want to natural log both sides because that allows me to get x by itself and x equals the natural log of 2. I want to natural log both sides and x equals, what's the natural log of 1? Well, if you remember it being 0. So the two solutions we have are natural log of 2 and x equals 0 for this one. All right, guys, so I've got one to give a shot on your own. Give this one a go, and we're going to go over it first thing. We're on to the next one.